Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video, I will be solving the Paper 2 exam for October-November 2018 Variant 1. So let's get started. Question 1 says the diagram shows part of a micrometer screw gauge. What is the smallest reading that can be achieved using this micrometer screw gauge? So it reads to 2 decimal places in millimeters. So they are all in millimeters here, and this one has 2 decimal places. So we choose B. Question 2 says a small light ball is dropped from the top of a tall building. Which graph shows how the speed of the ball changes with time? So if we're falling from a tall building, we will reach high speeds, which means there will be air resistance significant in the motion. So it will be the decreasing acceleration, then terminal velocity. So this part is a decreasing acceleration, and then we have horizontal line representing terminal velocity. So we choose C. Question 3 says a runner runs 300 meters at an average speed of 3 meters per second. She then runs another 300 meters at an average speed of 6 meters per second. What is her average speed for the total distance of 600 meters? So first we need the total distance divided by the total time, but we do not have the times. So we can say that the total distance is 600 divided by the distance over speed for each part of the section added. So 300 meters distance divided by speed 3, that's the first part. So this is the first time. And then 300 meters again divided by 6, that is the second part of the race. So this is the total distance divided by the total time, and this gives an answer of 4 meters per second. So we choose B. Question 4 says a helium balloon is tied to a top pen balance. A metal block of mass 100 grams is placed on the balance. The reading on the balance is 91 grams. Which statement can be deduced from this experiment? So the balance should be reading 100 grams, but because of the upward force exerted by the balloon, it appears to be lighter on the balance. So there is a resultant force downwards on the balance, but there is some part of the weight of the block is not accounted for due to the force exerted by the balloon. So which statement can be deduced from this experiment? The balloon exerts a downward force. No, it exerts an upward force. The helium has a mass of -9. We don't have negative mass. Helium has a mass of +9 grams that cannot be measured since the balloon is not pushing downwards on the balance. The resultant downward force on the top pen balance is 0.91 newtons. We can check that using G is equal to 10 newtons per kilogram from this here. And the weight is equal to the mass in kilograms, so 91 divided by 1000 multiplied by 10, and that would give an answer of 0.91 newtons. So this sentence is correct, so we choose D. Question 5 says a liquid has a volume of 0.040 meter cubed and a mass of 30,000 grams. What is the density of the liquid? And all the choices are in kilograms per meter cubed. So we need to convert this to kilograms before we calculate the density as mass divided by volume. So 30,000 grams, that is 30 kilograms divided by the volume 0.040, and that gives an answer of 750 kilograms per meter cubed. So the answer is C. Question 6 says a resultant force of 4 newtons acts on an object of mass 0.50 kilograms for 3 seconds. What is the change in velocity caused by this force? We can use the equation that the impulse is equal to force multiplied by time and is equal to the change in momentum, which is mass multiplied by the change in velocity, which is required in the question. So we can divide by mass, so the change in velocity is equal to the force, which is 4 newtons, multiplied by the time 3, divided by the mass, which is 0.5, and that gives an answer of 24 meters per second, so we choose D. Question 7 says which quantities are both vectors, which means they both have direction. Acceleration and force, they have direction, so the answer is A. Acceleration, pressure doesn't have direction. Density, no. Density, again, no. And pressure, so this is the answer. Question 8 says a moving ball with a momentum of 25 kilograms meter per second collides head-on with a wall. It rebounds from the wall with the same speed, but in the opposite direction. The time of the collision is 50 milliseconds. What is the average force exerted on the wall by the ball during the collision? So we can use force is equal to the change in momentum divided by time. And we have the final momentum 25. We have the same mass and same speed, so same momentum in magnitude. Minus the initial momentum, we will give it a negative sign since the final was given a positive sign. and they have opposite directions. So we divide then by the time, which is 50, and times 10 to the power of negative 3 for the milliseconds. This gives an answer of 1000 newtons. So the answer here is D. Question 9 says, which device is designed to convert chemical energy into kinetic energy? So an AC generator produces electricity, not kinetic energy. Battery powered torch that produces light. A car engine, yes, converts chemical energy from fuel into kinetic energy in the motion of the car. So this is the answer. A wind up mechanical clock, it does not use chemical energy, but it does produce kinetic energy. But winding up uses elastic energy or strain energy. So the answer here is C. Question 10 says an object initially at rest is dropped from a height of 12 meters. The change in gravitational potential energy when it falls to the ground is 565 joules. The frictional forces are negligible. What is its speed when it hits the ground? So we can use the conservation of energy. The initial gravitational potential energy plus the initial kinetic energy is equal to the final gravitational potential energy plus the final kinetic energy plus the wasted energy or losses. And the losses are zero because frictional forces are negligible. The final gravitational potential energy is zero because we reach the ground, so there is no height. And from rest, that means that the initial kinetic energy was zero. So we have the initial gravitational potential energy is equal to the final kinetic energy. So m times 9.8 times 12 meters, that's mgh, is equal to half times the mass times the speed squared, which is required here. We can divide by the mass on both sides of the equation, and we can use 9.8 times 12 divided by half, and then we square root to get the velocity, not the velocity squared. That gives an answer of 15.33 meters per second, and the closest answer here is 15.5. This is because at this year G was 10 newtons per kilogram, not 9.8. So the answer here is B. Another way of solving the question is to find out the mass using the gravitational potential energy and the equation mgh, and then reusing it in the equation to get the kinetic energy and half mv squared to get V. Question 11 says, a man climbs a ladder. Which two quantities can be used to calculate the useful power of the man? The weight of the man and the time taken only. No distances needed to get the work. Weight of the man and the vertical distance moved only. No, we need the time to divide work by time. Work done and time, yes. Work divided by time, that is power. Work done by the man and the vertical distance moved only. Again, time is missing. So we choose C. Question 12 is about manometers, so you can skip this question for the new syllabus. It says a manometer is used to measure the pressure of a gas supply. Which change gives a greater value of H? If we have the same pressure and it is calculated as rho GH, if we need to increase H, we need to increase the pressure or decrease the value of the density of the liquid, and the gravity cannot be changed. So either increase pressure or use liquid with lower density. Using a less dense liquid, yes. Using a more dense liquid, no. Narrower tube will not affect the result. Wider tube again will not affect the result, so we choose A. Question 13 says a wash basin has an exit pipe covered with a plug of area 12 centimeters squared. A chain is attached to the center of the plug to assist in pulling the plug away from the exit hole. The wash basin contains water to a depth of 0.080 meters. The density of water is 1000 kilograms per meter cubed. What is the force acting on the plug due to the water? So we can use force is equal to pressure multiplied by area because we have these values, but the pressure can be calculated also using rho GH. So it will not be a direct substitution. So we have the density as 1000 and G 9.8, the H depth 0.080, and we have the area 12 but divided by 100 squared, which is 10,000, or we can multiply by 10 to the power of negative 4 to convert it from centimeters squared to meters squared. That gives an answer of 0.9408, which is closest to the choice A here, again because G was 10 newtons per kilogram in this year, so we choose A. Question 14 says diagram 1 shows apparatus being used to observe smoke particles. Diagram 2 shows how a smoke particle moves randomly. Why do the smoke particles move randomly? They are hit by air molecules, yes. They are less dense than air. That would just mean that they will move upwards, not randomly. They are moved by convection currents, again upwards and downwards. They gain energy from the light. No, they would move the same way if there was no light. So the answer here is A. Question 15 says the gas in a sealed container is compressed at constant temperature. Which graph shows how the pressure of the gas changes with the volume? So if we are at constant temperature, pressure and volume are inversely proportional. So we choose the graph with the shape of an inverse relation, which is D. Question 16 says the distance between two electricity pylons is 60 meters. An engineer fits a cable of length 62 meters between the pylons, which is longer than required. Why does the engineer choose a cable that is longer than the distance between the two pylons? To allow for contraction, yes. In a cold weather, yes. To create a slope in the cable for electrons to flow that will not affect anything. To keep the current low and the voltage high, again, no. Reduce magnetic fields around the cable, no. So we choose A. Question 17 is about thermometers, so you can skip this question for the new syllabus. It says the diagram shows a liquid and glass thermometer. Which change increases the sensitivity of a thermometer? So a narrower capillary tube would work, a wider capillary tube decreases sensitivity. Thicker glass or thinner glass affects the response time, not the sensitivity. So the answer here is A. Question 18 says an object of mass 800 grams and specific heat capacity 250 joules per kilogram degrees Celsius is heated. It absorbs 5,300 joules of energy. What is the increase in the temperature of the object? So we can use that the energy is equal to the mass times the specific heat capacity times change in temperature. So the change in temperature is equal to the energy divided by the mass and the specific heat capacity. So we divide 5,300 joules by the mass, which is 0.800, since the unit for the specific heat capacity includes kilograms, not grams. And then we multiply by 250, which is the specific heat capacity. This gives an answer of 26.5 degrees Celsius. So we can approximate that to 27. So the answer is C. Question 19 says, on a cold day, a shiny metal rod feels colder to the touch than a plastic black rod. So feels means there is conduction. Touching also means there is conduction, since there is contact between two objects. Which statement explains this observation? The metal rod is a better absorber of infrared radiation. No, we are talking about conduction. The metal rod is a better thermal conductor than the plastic rod. Yes. The metal rod is a worse absorber. Again, no. Worse thermal conductor than plastic. No, metals are better conductors than plastic. So the answer here is B. Question 20 says one end of a copper bar is heated to a high temperature. Which mechanism is responsible for the transfer of thermal energy to the other end of the copper bar? So we have lattice vibrations of copper ions only, not only, there are free electrons. The lattice vibrations of copper ions and the movement of high energy electrons along the bar. Yes, the movement of high energy copper ions along the bar. Ions do not move through solids, so no. The movement of high energy electrons along the bar only, again, not only, lattice vibrations are included, so we choose B. Question 21 says plain water waves travel from a shallow region into a deeper region. They travel more quickly in the deeper region. Which diagram shows the wave pattern in the deeper water? So we are moving in this direction. From this section, it will bend away from the normal. This is the normal. So the bending will be like this. And the wave fronts will be perpendicular to the new wave direction. And the wavelength will increase. The one with the same shape is C. The wavelength increased and the direction is now bent away from the normal. Question 22 says which statement about the image formed by a plane mirror is correct? The image is larger, no. Smaller, again, no. Twice as far from the mirror as the object, no. It is the same distance. It is virtual, yes. So we choose D. Question 23 says a ray of light is incident on a glass air surface. The diagrams show the ray of light at different angles of incidence in the glass. So we have an angle that is less than the critical angle because there was refraction, and an angle equal to the critical angle. This is the critical angle since the ray is on the surface, and an angle greater than the critical angle. We can use this one to calculate the refractive index. The refractive index of any medium is equal to 1 over sine the critical angle of the medium. So we calculate 1 over sine 44. That gives an answer of 1.4396, which is approximately 1.44. So we choose B. Question 24 says different parts of electromagnetic spectrum are used for different purposes. Below are 4 statements about parts of the spectrum. One says infrared waves are used in television remote controllers. Yes. Radio waves are used to transmit television pictures from satellites, not from satellites. That uses microwaves. Ultraviolet waves are used for intruder alarms. No. X-rays are used for security checks, yes. So which statement are correct? That would be 1 and 4 only, so we choose B. Question 25 says iron is used for the core of a transformer and steel is used to make a bar magnet. Which statement explains these uses of iron and steel? Iron is a magnetic material and steel is a non-magnetic material. No, steel is a magnetic material. Iron is a permanent magnetic material. No, iron is a temporary magnetic material. Yes, and steel is a permanent magnetic material. Yes, that means soft and hard magnetic materials. So the answer here is C. Question 26 says a sheet of ice floats on water. A source of sound S is positioned at the edge of the ice sheet. 4 microphones are placed equal distances from S. Which microphone detects the sound from S first? That means moving fastest. So sound travels fastest in solids, so it would be through the ice to microphone B. Question 27 says a bar magnet is placed inside a current carrying coil. The diagram shows 4 different experiments. So we are moving the magnet slowly, removed from an alternating current in a solenoid. 2, we have removing the magnet slowly from a coil containing direct current. 3 has a changing alternating current, but we're not moving the magnet. In 4, we're not moving the magnet and we have a varying direct current. So the question says, in which experiments is the magnet demagnetized? So using direct current does not demagnetize, it magnetizes or increases the strength of the magnet. So using alternating current would work. Either we are moving the magnet through the coil or changing the magnitude of the current. They both will work. So that's 1 and 3. So we choose B. Question 28 says the diagrams represent 2 different electric fields. A single electron is located in each of the fields. Which row gives the correct direction of the force on the electron and the field in which there is a large force on it? So a large force means a stronger field, and the stronger field has its lines closer together. So field 1 will have the stronger force. So field 1 and field 1. And an electron experiences a force opposite to the direction of the field. If the field is pointing upwards, then the force would be pointing downwards on an electron because it's negatively charged. So the common one here is A. Question 29 says the resistance of a component in a circuit is found using an ammeter and a voltmeter. How are the ammeter and voltmeter connected? Voltmeter and ammeter both connected in parallel, no. Voltmeter and ammeter both in series, no. Voltmeter in parallel, yes, with the component, and the ammeter in series with the component, yes. So we choose C. Question 30 says the table gives data for 4 different electrical devices. Which device develops the greatest power? And we have voltage and current. So we can use the equation power is equal voltage multiplied by current. So 12 times 3, that is 36. 110 times 0.4, that would be 44. And 400,000 for kilovolts times 0.10 times 10 to the power negative 3 for milli. That would give an answer of 40 watts. 240 times 0.20, that would be 48. So the greatest number here is 48, so the answer is D. Question 31 says the circuit diagram shows a fixed resistor R and a thermistor T used in a potential divider circuit. VR and VT are the potential differences across R and T respectively. What happens to VR and to VT as the temperature of the thermistor decreases? So as the temperature decreases, the resistance of the thermistor increases and the voltage across it also increases, so VT increases. And since the total voltage of the battery is the same as the voltage at the upper resistor increases, the voltage on the lower resistor decreases. So the answer here is A. Question 32 says the circuit diagram shows a power supply connected to some circuit components. In the diagram, P and Q are the terminals of a DC power supply. Under which circumstances does the ammeter show a reading other than 0, which means that there is a current here and the current is flowing in the right direction with the diode, so to the right here. So when P is positive or negative, ammeter always reads 0, only when P is negative or only when P is positive. So for the current to move in this direction, it must be coming from this direction. And the current always goes out from the positive terminal of a battery. So P must always be positive. So we choose D. Question 33 is about logic gates, so you can skip this question for the new syllabus. It says a diagram shows a digital circuit with 2 inputs and 1 output. What describes the action of this circuit? So we have to try the possibilities of the inputs and outputs. So 0 and 0, 0 through a NOT gate that gives 1, and again through a NOT gate here gives 1, and 1 here. 1 and 1 through an AND gate will give 1, and 1 through an AND gate with another 1 will give also 1. Now we try 0 and 1. Again, we will get 1 from the upper one, and 2 zeros from these. 0 and 1 from an AND gate that will give us 0. 0 and 0 through an AND gate that gives 0. Now we try 1 and 0. 1 will be converted to 0. 0 will be changed to 1 here. So 1 and 0 again, that will give us 0. 0 and 1 through an AND gate will give us 0. The last combination, we have 1 and 1. That will be converted to 0, 0, 0. 0 and 0 through AND gates, that gives 0. So going this way with these inputs, the combination gives 0 whenever there is 1 in the inputs. That is the opposite function of an OR gate. So this is an OR gate. So we choose C. Question 34 says either a fuse or a circuit breaker can be used to protect electrical cables from large currents that could cause overheating. When a fuse is used, where should it be connected? And when a circuit breaker is used, where should it be connected? They are both supposed to be on the live wire, so on wire X here. So X, 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 so we choose A. Question 35 says there is a current of 3 amperes in a conductor. The current is changed to 6 amperes, so that's multiplied by 2 in the opposite direction. Which effect does this have on the magnetic field around the conductor? So it decreases, no, it increases the strength of the field and acts in the opposite direction, not the same direction, because reversing the current reverses the direction of the field. So the answer here is C. Question 36 says a wire is placed in a strong magnetic field. When a current is passed through the wire, it moves upwards as shown. The current is now reversed. In which direction does the wire move? So reversing the current only without reversing the field reverses the direction of the force and movement. So it was moving upwards, now it will move downwards. So we choose A. Question 37 says which diagram represents the structure of a neutral atom? Neutral means the amount of positive and negative charges are equal. So here we have 1 positive charge and 2 negative charges, so it's not A. Here we have 2 positive charges and 2 negative charges, that will work. 2 positive charges, 1 negative charge, not C. 3 positive charges and 2 negative charges, that's not D, so we choose B. Question 38 says when a uranium-235 nucleus absorbs a neutron, it becomes unstable and undergoes fission. The fission process produces a barium nucleus and a krypton nucleus and 3 neutrons. The fission process is represented by the nuclear equation shown, which symbol represents the resulting krypton nucleus. So we need to balance the numbers on top and on the bottom. So using the bottom, because we have 0 here, it's easier. So the total of these two is 92, and we subtract 56 and 0. That will give an answer of 36. And we check the choices for 36. We have 36 here and 36 here. So it's not B nor C. Now we check the upper numbers. So the total of these two would be 236. And we subtract 144 from the right side, and 3 times 1, so we subtract 3. That gives an answer of 89, so it's not 91, so we choose A. Question 39 says the diagram shows the path of different types of radiation, X, Y, and Z. Which row correctly identify X, Y, and Z, alpha, beta, or gamma? So X can pass through 2 millimeters of plastic but is stopped by 10 millimeters of aluminum, which means this is beta radiation, so X is beta. Y is stopped by plastic, which is very light, so this must be alpha. Z is stopped by 50 millimeters of lead, so this is the strongest one or the most penetrating one, which is gamma radiation, and the common one here is B. Question 40 says a scientist measures the count rate of radioactive sample in a laboratory over a period of 12 weeks. The background radiation count rate in the laboratory remains constant at 20 counts per minute. The table shows the scientist's results before the background radiation count rate is taken into account. In which range does the half-life of the radioactive isotope lie? So if we take the first count rate 100 and then we subtract the background, we get the corrected value of 80, then we divide 80 by 2 for 1 half-life, we get 40, and then we add the background again, 40 plus 20, that gives us 60, and 60 is right in between these two values, so it's between 4 weeks and 6 weeks. So between 4 and 6 weeks, between 6 and 8 weeks, 8 and 10 weeks, more than 12 weeks. So we choose A, between 4 and 6 weeks. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing, and I will see you in another video.